Hey class, today we are going to learn another way of solving a system of equations. So, if you'll remember, last class period, we learned about how a system of equations is simply more than one equation in the same problem. And we learned how to solve that system by graphing. When we were graphing in order to solve, we graphed both equations on the same coordinate plane. And then my solution was the point where they crossed, where the lines crossed. That's a better way of saying that. And so all of our solutions were written as a coordinate point, an x comma y. This is our solution to a system. This is our answer. But sometimes what we're going to find is that if I give you an equation, actually, you know what? Let's look at it this way. Sometimes I forget that I can get my boxes on here. Okay, let's say I give you an equation, two equations in my system, and then I graph them, and this is what I get. And I said, okay, well, what's the solution? And you're going to say, well, this is my point. This is where they cross, but I would have to guess what the coordinates of that are. I mean, is it 1.5? Maybe, comma, 1.5. That's close. But what if it's not 1.5? What if it's 1.6 and then comma 1.4? When I'm looking at a graph, I cannot know exactly, in particular, when I'm dealing with decimals. So decimals are a reason why I need more methods than just graphing. So we're going to actually learn two more methods of solving a system of equations that aren't using a graph. So my first new method that I'm going to tell you guys about today, and I can take off the graph lines because we're not doing that. Our first method is called substitution. Substitution is our first new method after graphing. Okay. Now, we know what substitution is. In fact, when we were doing problems at the end of the lesson last time, we were asking ourselves, is a point a solution? And then you did substitution. That looks like this. In your book, when you did problem number 8 on page 239, you were given the coordinate point 5, -6, and this system. And so then we were asked, is this coordinate point a solution? I don't know. I have to check and see. So what do? I take the coordinate 5, -6, and I'm going to plug each of these numbers into the variables and check and see if I get a true statement. When I take 5 and plug it in for the x, this is substitution. I'm going to take out the variable and I'm going to put in the number. And I'm going to check and see, do I get a true statement? But this whole plugging in is substitution. So up here by substitution, I want you to write plug in. This is what we actually do. We've done this here with numbers. So we say 6 times 5 is 30. 3 times -6 is -18. And then we say, is this 12? Is 30 minus 18 12? Yes, it is. So that one checks out. But then we have to do it again to the other equation. So we have to plug into both, unless you plug it into the first one and you get a false statement, if it's not true, then you can stop and be done. Otherwise, we have to plug it into both. So we're going to say 4 times 5, we're going to substitute, and then plus substitute the -6 in, and see if that gives you 14. 4 times 5 is 20, minus 6, is that 14? Yes, of course it is. So it checks out in both. So the answer is yes, this point is the solution to the system. So this is doing substitution. Well, this time though, if I'm going to use substitution in order to solve, we're going to have a problem that looks like this. Y equals negative 2x minus 9 and 6x, oops, not equals, 6x minus 5y equals negative 19. Okay, so in this problem, I want you to solve. I want you to find the solution. So you are finding the point that is the answer. Our answer is going to go in here. But this time, I don't want to graph this. Okay, if I were going to try and solve the second equation for y in order to graph, I'm going to end up with decimals and fractions, and I don't want to deal with that. So another method is to substitute. If I'm going to substitute, the first thing that I need to do is get one of the equations to either be a y equals or an x equals. It doesn't matter which variable is alone on one side of the equal sign, but we need a variable to be all by itself. So in this problem, I have that. I have a y equals. Okay. Once I get a y equals, then I'm going to do the substitution. Okay, well, what am I going to substitute? So in this problem, I have y equals negative 2x minus 9. See, what we're saying is that negative 2x minus 9 is the same thing as saying y. So in the other equation, I'm going to put negative 2x minus 9 in for the y because these two things are equal. So I'm going to take out the y and put in negative 2x minus 9. I'm going to make sure to put parentheses around it because I'm going to have to distribute. Oh, I thought I was going to sneeze and I didn't. Okay, sorry about that. Okay, so recap. When I have a y equals something, put that something in for the y in the other equation. And that is beneficial because now when I look at this long line written in blue, this only has x's in it. And I know how to solve equations that have only one variable in it. So now for my third step, I'm going to solve for one variable. So I'm going to distribute my negative 5 here. So 6x, a negative 5 times a negative 2 is a positive 10, and the x comes along. Negative 5 times negative 9 is a positive 45, and that still equals negative 19. Now watch out for the next step because in the next step, we want to combine like terms. This is still the step where I get the most mistakes. So I'm going to find my like terms and I'm going to combine them. So 6x and a 10x is a 16x. Okay, we are not subtracting 10x and subtracting 10x because right now we're working on the same side of the equal sign. So 16x plus 45 equals negative 19. Next, I'm going to undo that adding. So I'm going to move that negative 45 to the other side. And those negative 45 and positive 45 numbers cancel. So 16x equals, I'm plugging this in my calculator, negative 64. And then we're going to divide by the 16. And we get negative 4. So x equals negative 4. Now, this is not my answer though, because my answer has to be written as a point, meaning I need an x number and a y number. Well, I can go ahead and put this negative 4 in for the x spot. But now I need to figure out, how do I get a y number? Well, that's when I come back up to my original problem, or wherever I had my y equals part of my equation. And I'm going to take this negative 4 and I'm going to plug it in for the x. See, I always circle the part at the beginning that is the right-hand side of the equation where I have my y equals. I always circle it or box it because that's going to draw my eye back to this spot when it comes time to finishing off my problem at the end. Because now, from my final step, once I've solved for one number, I'm going to plug that number back in to my x equals or y equals equation. These are my steps. Okay. So at the very end, I'm going to come back over here. I'm going to go ahead and work my problem down here in this last little bit of space. So I'm going to say y equals negative 2. And in the x spot, I'm going to plug in negative 4. And then minus 9. Okay, do you see how I did another round of substitution? So negative 2 times negative 4 is 8. And 8 minus 9 is negative 1. So now this number, negative 1, is what goes in the y spot of my answer, of my coordinate point. Okay, let's do another one because these just take a little bit of practice to get the hang of it. Let's start off with this problem. This time we're going to say 4x plus y equals negative 3. And x equals 6y minus 7. Okay, so my step said to find an equation that is either an x equals or a y equals equation. That's happening this time in my second equation of my system. So here's my x equals, and I'm going to circle or box this side of the equation, because this is the spot that's going to go in for the x. I'm going to take 6y minus 7 and I'm going to plug it into the other equation. I'm going to plug it in for the x in that equation. So it's going to go right there. So this time I'm going to take 4, take out this x, and we're plugging in 6y minus 7 in its place. And then I have plus y equals negative 3. This finishes off the rest of my original equation. Now I'm going to solve. Solve for what? Well, the only variable that's in this equation, and this time that's the y. So we're going to solve by first distribute So we have 24y minus 28. And then the plus y equals -3 hasn't been changed at all. So we're just going to copy that down again. Our next step is to combine like terms because I have y's on I'm sorry, I have y's on the same side of my equal sign. They're not on different sides, they're on the same side. And so because they're on the same side, we are going to combine. And so 24y plus another y is 25y. The -28 hasn't done anything yet. And now we're going to solve for y by adding the 28 over to the other side. 25y equals 25. And then solve for y. This is 25 times y. So I'm going to undo multiply by dividing. And so we get y equals 1. Okay, so now if we set up our coordinate point that is going to be the answer, this time the number 1 is my y. So I need to make sure to put that number in the y spot. So we're going to put it here. Then in order to find the x, I'm going to plug this number in for y in this spot right here that I boxed at the beginning of my problem. So I'm going to say x equals, and I'm going to put in the 1 for the y. So 6 times 1 minus 7. And then I'm going to evaluate this. What is 6 times 1? 6 minus 7 is -1. So my -1 needs to go in the x spot of my coordinate. And this is my answer. I'm going to tell you that if you do all of the steps right, but you don't write your answer as a coordinate point, I'm going to take off points. It is very important to make sure that your answer is written as a point. All right, I have one more example for you because there's something else that I can do. Yeah, we're doing good on time. Okay, there's something else that I can do to make the problems just a little bit harder. So this is my final example. What if I give you -x plus y equals 3 and 3x plus y equals -1? Okay, well, how is this problem different from the ones that we've been doing before? Well, in all of my other examples, I started off my problem by having one of the equations already written as an x equals or a y equals. But this one's not like that. In both of these equations, the x and the y are on the same side of the equation. So this one actually has like a step 1/2. It's a step that I have to do before I can do step 1. And that is get the equation, pick one of the equations and get it to be equal to an x equals or y equals. Okay, so here, oh, I actually wrote that. Look at that. I was ahead of the game. I actually wrote for step number 1, get one of the equations to be x equals or y equals. Okay, so here's where you have different ways of doing the same problem. When I look at this problem, I want to find a variable that doesn't have a number in front of it. And I want it to be a positive number, if at all possible. So like a plus y or a plus x. This would be a good spot, or this one would be a good spot. Either one would work, but you pick one. So you pick a variable that technically, what's the number in front of this top y? Technically, what is it? It's technically a 1. So it has a 1 or a coefficient of 1. Let's do that. Has a coefficient of 1. meaning the number in front of the variable is 1. But remember, when this is happening, you don't see a 1. The 1 looks like it's invisible, okay? There we go. You don't actually see that 1. It's invisible. So we're going to pick that variable. So, okay, we're going to pick the y. And then once I pick that, I'm going to solve for the y. So solve for that variable that you picked. Mm, Okay, so when I have my equation negative x plus y equals 3, how would I get y by itself? I need to move that x over to the other side. I can only move things to the other side by adding or subtracting. Since this is a minus x, I'm going to move it by adding the x to the other side. It doesn't matter if you put that x at the back or if you want to make it x plus 3 to make it look a little bit more like what we've been using for mx plus b. Okay, so it doesn't really matter. Now that we have a y equals equation, this is the part that I circle. Remember, we circle or box the part that's on the other side of the equal sign, the one that, if it's y equals whatever this is, I'm going to circle it because this equation here is the one that I solved for, that I solved for y. So I need to plug this in for the y in the other equation. I have to make sure that I go to the other equation and I'm going to plug this thing in for whatever is equal to it. So we're going to have 3x plus, okay, take out this y, and we're going to put in 3 plus x in its place, and that's equal to negative 1. And now we're going to solve for x. Notice how this time there is not a number in front of my parentheses when I did my substitution. So when that happens, technically what we're saying is that we don't even need these parentheses. So this is just the same thing as saying 3x plus 3 plus x is negative 1. And so we're going to combine like terms. So 3x plus an x is 4x plus 3 equals negative 1. Then we're going to solve for x by subtracting the 3 and then dividing by 4. X equals negative 1. So let's get our coordinate written over here because this is going to be where I put my answer. And so I'm going to put negative 1 in the x spot. Now I have to figure out the y. Well, where do I go in all of this? Again, we have quite a bit of like steps going on here. Well, this negative 1 is going to go in the spot where I've already got something else boxed. That's why I do that. So we're going to say y equals 3 plus negative 1. Well, that's the same thing as saying 3 minus 1, which is 2. So y equals 2. That 2 is going to go into my coordinate point in the spot of the y. This is my answer. All right, now you've got a couple of examples. I didn't give you any examples right here that had fractions in it, though, which is the whole reason why we want to have another method. So we're going to do some examples that have fractions on them in class together. I hope you guys have a great day, and we'll see you next time in class. Bye.